Assalamu alaikum wa rahmatullah. Welcome, my dear students, to Advanced Mobile Application of second week. So for this week, this one for second week. So for this week, we are going to focus on different topics. Let us see just what we did on last week. Last week we covered part one of the tried notes about Flutter framework, introduction, why to use Flutter, why to learn that language. And we started working on introduction to that programming language, like the OOP language. And we created a simple data class by using a Dartpad, the online editor or compiler. We defined a bicycle class and a constructor for that class. And we you saw how to format your code, instantiate and print bicycle instance, and to improve the output of that bicycle to become more clear, so we can understand the values for each let us say instance or member of the class. Then we worked on adding read-only variables by using an underscore. You start to make the private variables, and then using optional parameters instead of loading, add the rectangle constructor, and creating a factory, implementing an interface using that for functional programming will be covered by this week. So let us start with using optional parameters. So if we look at here, this one, adding a rectangular constructor. So here in this rectangle example, we started already working on this rectangle class, also offered by Java tutorial to help you about the OOP on Java. And Java overloading shows overloading constructors. Common practice, which is a common practice on Java, as some of you might know about this one. We should create many constructors with the same name, but with different number of input parameters. That doesn't support overloading constructors and handle the situation different ways. If we click on this one to see how. Okay. So this is a rectangular class written in Dart language, which is similar to Java. We imported Dart.math to get a point origin. For the rectangular shape, we need this point. If we make it as comment, you can see you will get an error, a point origin. It will tell you this is point the class is undefined because this one is imported from a Dart.math library. All right, and in the main function, we are going to see what we are going to do regarding constructor. So adding a single entity constructor that replaces all 4 constructors on Java. If we look at the Java example, let me show you. We need to create here, to take all the possibilities by creating, if we look at where the constructors here. We have 4 constructors. The first one, as you can see, without any input parameter. Then second one, if we look at here, this is without any parameter. Then the other one, if we look at here, it is only with one parameter, LP. The second one which has 2 parameters, and last one has 3 parameters: the point, the width, the height. So we should create constructor for each case that we want to create an object. Sometimes maybe we want to create a default object with 0, 0 value, rectangle, a point this is. Then other times we need to we have only value of one of the, let us say only point value we want to change. I want to set. Other times we have width and height, and the point we will just keep it 0, 0, the default value. And other times maybe we might get all the values that we want to get object with all these values, which has all these values. Then these others are methods. So if you look at here, 4 constructors are there on Java. If we go for Dart, we can make it only on one constructor is enough. Adding this single empty constructor up here, So this constructor will replace the other four constructors. How we can add the constructors? If we come to the class, we have to put the constructor, as you know, inside the class. So this is the rectangular class, and here inside the class I pasted the code for the constructor, and you can make it only by using only one line of code. It's enough to point the constructor with the, we are using here, as you know, this one is not important to be used usually on Java. We don't have, let us say, curly braces, but we are adding them here to say these are optional parameters. Without those, all of them will be compulsory. If we put only parameters, let me check. All of them, when you create objects, you have to put all of them. I mean, all the variables, you should have them one by one, and to be compulsory. So here maybe we need to name parameters must be enclosed in curly braces. It says as long as you have many parameters, you have to use the curly braces for them. So to set it optional to become optional. So this is on that. You have to put the curly braces if you have any parameters. So to become optional thing. Then we put a semicolon. Without semicolon, the compiler here will ask you, you should provide function body. So this is the function body if you want to provide, and you can write here your code about, for example, what you are going to do with this constructor if you have some code. But this is not necessarily if we don't have initial values, like just if we want only, if we have only 0, if we want to put, without doing any action in the constructor. So this is very enough, and this without this semicolon. Because the job of constructor to create an object with default values. So we did all these things inside by this one line to replace the 16 line of code in Java. So the origin, this dot origin and this dot wait and height use the short-hand trick for assigning instance variables inside constructor declaration. So this is the meaning of shorthand trick using curly braces to do it on one line. This dot origin and weight and height are optional name parameter. They are optional. So it means sometimes you can, when you create objects, you can create objects without writing any one of them when you want to call the constructor, or you can put 1 or 2 or 3. It's up to you. It will be accepted in any way. Name parameters are enclosed by curly braces. This dot origin equals .00, this part, first one, syntax specifies a default value of .00 for origin instance variable. The specified default must be a compile time constant, the default value. This constructor supplies default values for all 3 instance variables. It will give them all like zeros. Adding the following to string function to the rectangular class. So when we print like any object, it will print instead of like as we did with the bicycle. If we look at here now, I will take the print statement without overriding the string, and we will see the problem that we faced last week when we didn't like override the string function on the class. So let me just show it to you now. On the main, let us say now I have constructor. I want to create object. So now we have many kind of objects here. With 3 parameters, 2 parameters, 1 parameter, without any parameters, it's all accepted. The declaration main isn't referenced. Okay, maybe you have something here. The declaration main isn't referenced line 12. So now we have 2 main functions. We have to delete one of them. Sorry for this. Okay. Now if we run it, you will get, as you know, instance of rectangle, and this message is really like ambiguous. It's saying yes, the message is correct. Like each one of these print statements is printing like instance of rectangle class object, like object of rectangle class, which is correct. But we don't want this one. We want to override the string, like to string, for example. Here we can override to string to print something. We can just write at over. Right, then the string function it will return to string, and then here string it will return and to string. So here we can use, as you know, the fat arrow to write the code. So if you look at here on the here, we're overriding to string function to do this one, to write this code. Origin, then between two parentheses, we put like a dollar sign, and here we inside dollar sign we want to show like an expression, let us say origin.x, then comma, another expression origin.y, and then comma width and dollar sign for the width. So dollar sign here either to use with the variable name or with an expression to be evaluated during the runtime. So let us just take this line to print the same, exactly the same thing. Okay. So now the origin, I will just click on format to make it better. Okay. So now format is not formatting change. Now when we override this one, it will show. Let me see what's wrong. If we look at here, string, okay, to string origin. Okay. Maybe they should be the same line. No main method found. Okay, so it seems we didn't close. I didn't close the rectangular class. I have to close it first, and then I can run it. As you can see, now we have the opening and closing brace correctly. So now we are going to get for each one of them. As you can see, the origin.x for each one of them. We have here 10, then 20 origin.y, then width we are going to print, which is 100, and the height 200, as you can see here. Then the other one, we have 10, 10. Then we didn't write any width and height. It will be default value 0, 0. So, and the others, we have only width 200. All other variables will be considered as 0 from the constructor. So this is how it works, like creating objects and we'll overriding string function to print whatever that we want to show. So that constructor of rectangle is one line of code, as you have seen here. There's only one line of code. This is that constructor. While Java has 16 lines of code for equivalent constructors. You have to create there four constructors to make the same thing that we are doing on one line of code. So that's why maybe here the constructor is more powerful than Java. I mean, especially in terms of like less coding and higher flexibility that we have seen. Creating the factory. Factory is common way used like as a design pattern in Java, have several advantages over direct what? Object instantiation, such as hiding the details of instantiation and providing the ability to return subtype of the factory's return type, and optionally returning existing object rather than a new object. Also, you can use it for that thing. So this step demonstrates two ways to implement the shape creation factory. First way, we can usually create a top-level function for the factory. Second way, to create a factory constructor. So we have two ways to work on to implement, for example, shape factory in this example, or another example, either by creating a function or a constructor. Again, a factory, if you look at here, a factory is used for what? Is used commonly used design pattern in Java, has several advantages over direct object instantiation. It's usually used for hiding the details of instantiation and providing the ability to return a subtype of the factory's return type instead of the original type or parent type. And it could be optionally used for returning existing object rather than new object. So for this exercise, we will use a shape example. Okay, so if we look at this example now, we have a shape. We can just open it in that path to see. Okay, so now we have this is like a dot map. If we just put double quotation, double slash to see where is this library has been used. It's used for pi and power. Both these, like this constant and this function, we are getting them from this library. So we can just now remove this one and comment. Then if we run this one, it will print circle and square as final, because we don't want to change like values to be constant during the runtime. So circle parameter will what constructor is calling number 2. So where is circle? Circle is here. Class circle is implementing a shape. So this is abstract class to be like, because we don't have interfaces on that, we have only abstract classes. So you can implement these classes if you have like variables or abstract methods. You can call use them in implementing them. So here this shape class is implemented by other two subclasses. Let us say this circle and square are implementing a shape. Then inside the shape, we have to, as long as we have this variable inside the class area, we have to use it in both classes because it's abstract class. So you have to implement like it's, area. Let me show you something. If we now put here comment for the area, what will happen in each class? Our compiler will object on this one, doesn't accept. It says missing concrete implementation of getter shape area on circle and what else? Square. Both of them, you have to implement what? Implement the getter function area, because it exists inside the abstract class. This is the meaning of the class. You have to implement its function. But the implementation is up to you how to implement. Implementation code is up to you. The important thing for that compiler is that you have to implement this one. Use this variables or methods inside the abstract class. So the circle shape, it has final num radius. Then circle, this is the constructor, circle, this dot radius is accepting only one parameter called radius. Then in num get area, this will get area when you call area for that class, when you create the object instance, like instance of the circle class, and you want to get the area, it will get the area for that instance, for the type of circle object by using this, let us say, expression or equation. And if you are creating the square object, it will use, if you want to get the area for that object, it will use this area of that square object. As you can see here, we write circle, which is created this circle object by using the circle constructor. So when you write circle.area, it will go and find the area inside the circle class, which is this one. Same thing also for the square. So we will get like this, we are writing same number, 2, 2, but we are getting different output because we have different equations for the circle and for the, what else, the square. Okay. So this is regarding the fact that this first part, let's say. Now, in the console area, you should find that supports abstract classes. You can define multiple classes in one file. A dot math is one of the dot core libraries. Other core libraries, we have dot core and async and the convert and the collection. All other libraries, they can do, you can use them for different other things. By convention, dot library constants are lower camel case. So like using a pi instead of with small letters rather than pi capital. If you are curious about reasoning, see like the style guideline for about constants for that. The following code shows two getters that compute the values. This one, num get area with the fat arrow to pi by power and the radius and two parameters, and the other getter for what? For the square. So creating a top level function. Implement the factory now. Now we are working on first word, creating top level function. Implementing the factory as a top level function by adding the following function at the highest level. So highest level here, keep in your mind always, it means outside of any class. When you say highest level, you will take this code and put it outside of any class. Let us take it. We go to the that and we put it outside of the classes. For example, we put it here. I'll click format again just to make it better, and we can run it. Now nothing will happen, as you can see. We didn't use shape factory yet. Shape factory begin if type equals circle. So let us see how to implement this one. Now we put the function, top high level function, but without using this one. As you can see here, we are using the constructor. Invoke the factory function by replacing the first two lines in the main method with using the function, calling the function. So let us take this one, implementation code, and we will replace, as mentioned, the first two lines in the main function. Instead of calling the constructor, we are going to call what? Call the function. Click on format. So from final circle, again, final square, same thing. But here equals, instead of calling the constructor, we are going to call what this time? We are going to call shape factory for us. Shape factory will do the trick for us. We'll call constructor. So we'll do what with shape factory. It will take only one integer type. That type, for example, if it was circle, it will, here when you run it, it will come and check. If the type equals circle, it will return the constructor, this one. Circle 2. And if you type here on the argument, if you type square, you will get what? To return square 2, number 2, with for square. Then if we write something else, let us just run it, it will work now without any issue. But if we write something else, it will throw an exception. Can't create a type that you have written. For example, I replace circle with triangle. Okay, run it. Now you will get cannot create slash t space, cannot create a triangle. Okay, I hope it's clear for you. Now observation function is called when with any other string than circle or square, it will throw, if it's called with this any other input argument, or it will throw an exception as you saw earlier. Adaptive brigade defines the classes for many common exceptions, or you can extend the exception class to create more specific exception. As in this example, you can throw, for example, a string that describes the problem encountered. When exception is encountered, that code records uncode to see information that's more helpful. Rather, the code will try and catch to get the exact, as an optional exercise, you can check this one. We try and catch example. It is the same way that we were using on Java. Let me show you now. Let's try. So if this if they worked, one of them, for example, if they are working all, okay. If one of them doesn't work, for example, it will go and create, it will print what? It will catch error, it will print error message. As you can see, can't create a triangle because triangle we don't have it. Inside the shape, we have only square and circle and square. So try and catch also work instead of only throwing the error message. To use a single quote inside a string, either skip the embedded quote using like a slash, also you can slash t, for example, to give a space, create $sign type, or specifically use a string. So you can use single quote, or you can use double quotation for a string. It's up to you on that. Then the second way is creating a factory constructor instead of a function, using that factory keyword to create a factory constructor. So you have to use the factory keyword here in this case instead of what, use the factory keyword to create a factory constructor instead of the function. Adding the factory constructor to the abstract shape class. So inside the class, abstract shape class, we are going to get a factory, and this one I put this code inside the abstract shape. So where is the abstract shape? This one. I'm opening another example, sorry. This one that we were working on. I will paste the code that I copied. Format. We are getting error. Factory shape begin. Okay. If then the other if statement also the beginning. Then throw. Okay. Now we close this one. This one is extra, I think. Yes. Okay. So after we did this part, let us go on the other. Replace the first two lines in the main with this part. Now we should call what? The shape in this. Okay. We should call the shape factory now. constructor instead of calling the function. So here, first line was share factory function name. Now we'll call the constructor. Okay. Let's see if it works. Okay, it works perfectly. So now shape will call what? We'll call shape, we'll call constructor, and the constructor will do what? The factory constructor. This factory shape, factory constructor will check the input type. So it is the same thing, but now we're using the constructor instead of function. The function. Delete the shape factory function. Okay, let's delete it. Now this is shape factory. This is a function which will return a shape. I should delete this one because already the constructor is doing the job for that function, which will only also still working now the code without any issue. Implementing the interface, that language doesn't include, as I said earlier, interface keyword because every class defines as an interface. Adding a circle mock class that implements the circle interface here. So we can add this class, circle. So you should see a missing concrete implementation error because circle mock doesn't inherit the implementation of the circle. It will only use its interface. Fix the error by defining the area and radius. This is variable. So if we fill this line, we'll get an error because we are not implementing the variables of the circle. So let us test this one by ourselves to see. If this is true, I'll put it here. After the square implement, okay, I'll put here. Missing concrete, yes, as it's mentioned. Now when I add the class circle mock, it says missing concrete implementation of getter, area, and radius. We have to implement both of them because if we look at circle, it has a radius and it has an area. So both of them should be, when you write implement, class implements the other class, so you have to implement it like whatever you have inside that one. So we can just get, for example, num area and num radius. We can either write this one or we can just, for example, num area and num, what else? It was the radius. Okay, now the error is gone because you just use the this variable. So it's only use its interface fix the error by defining the area and radius instance variables, even though the circle mock class doesn't define any behavior, as you can see. It's valid in that. The analyzer raises no error. And the area instance variable of circle mock implements the area getter of the circle. So area, it will use the area equation on the circle. This equation, where is the circle? This one. Okay, when you use the area inside circle mock, if you use it later, get any object by this class, it will use that equation or expression because it's implementing the circle class. Using that for functional programming, so we can do like many things, like passing functions as an argument, assigning a function to a variable, deconstruct a function that takes multiple arguments into sequence of other functions that each take a single argument, also called curry, and create an inlet function that can be used as a constant value, also called lambda expression, which were added to Java and JDK8, I believe. It does support all of these above features, in that even functions are objects and have a type function. This means that function can be assigned to a variable or passed as an argument to other functions. You can also call an instance of a data class as if it were a function, like in this example. If we look at this example, here ownable function, wanna be function. Here we are creating object variable or wanna be function WF equal wanna be function. So we are here calling let us say creating object called WF by using constructor of wanna be function. Then after that variable out equals, we are calling using the object WF. We are writing 3 parameters like input parameters. it will go and check inside that class which function has 3 parameters. It will call that function by using the object name WF, and then we have only one function with 3 parameters A, B, C. This one, and it will print for you, of course, like here as you can see, printing variable A, variable B, variable C. What is variable A here? It will be hi, and variable B will be there, and variable C will be gang. So hi, there, gang. When it will be printed, of course, nothing happens yet inside the main function by using the short fat arrow, because only we have one line of code. If you have more than one line, you have to replace it, as you know, with this one, with the curly braces, if you have more than one line. But as long as you have one line of code, you can use the fat arrow or this one. It's up to totally up to you. So we are printing it out, which is what a variable calling call function with these parameters. It will print the above. Okay. Then opening the output here, you should look like this one, like the following. This one regarding the following example is imperative, not functional style code. So like line by line, we are creating an array. This array, we are saying here for variable length will go in values, through the values, this for loop, from first value, 0 index until maybe 4 index. If we have 5 or 6, 4, 5, 6. So from 0 to 5, it will go from 1 until the last element. And doing what? A print screen. We'll just write, we'll call this function plain screen and length. So length at the beginning will be, for example, here, as the beginning, for example, first element 1, the second time it will be 2, and until 50. And to the print, for example, each time it will do what? To the print A, then $sign begin, A letter multiplied by the length. So at the beginning, the length will be, for example, 1. So 1 by A. So A capital and A small and H with exclamation mark. Second time, I will multiply by, for example, 2. It will be double A, 2 and double A, and so on. So if we look at here, this is the output according to what I said. You can try out this one on your computer, on your PC. When using string interpolation, the string, this one, $sign and A by length, evaluate to the character A repeated by length times. So converting the imperative code to functional, remove the imperative for loop in the main and replace it with a single line of code. For example, if you want to go to the functional by using the function, so we can use this one, values.map screen, and dot for each. This function will do the iteration, a print. For each item on the, let us say, on the array, it will just print everything. So we can do this one. I think in this line, let us go and check it. How we didn't open this example yet, so we can open it here. Okay, so by replacing this line, instead of using the for statement, I will delete it. I will copy that line, and that's it. I will get the values. So the array name dot map. The map will take this data collection, will take a screen. Function will call a screen function, and screen function will work with each input parameter, with each what? It will print for each print. So it will print for each element of the array. It will go element by element, do this action, which will print the content of the values array. So this is how we can, or we can use the iterable feature. Iterable like feature, like we call list and iterable class supports fold, where, join, skip, and more. So in this case, we will just add values, array name dot skip one, skip first element, take the other 3 elements on the map, and for each one of them a print. So it will ignore number 1, it will go and for double and triple, and maybe we have 5, I think, and so this is what will going to be applied. Congratulations for completing this code lab, which is brought by Google. And you gain knowledge like for some difference like between Java and Dart. And that is, by the way, it's easy to learn. And in addition, like it has like these are code libraries. You can read about them, and there is like also a set of available packages to increase your productivity. Dart scales well to large applications. Hundreds of Google engineers are using Dart to write mission critical applications. That brings in much of Google's like revenue. Next step, if you want this like I'm exercising like a 20-minute code lab that we did, maybe it's not enough to show you all the difference between Java and Dart. So for example, this code lab hasn't like covered the async instructions, let's say, which allows to write sequence code. You can check this example and method cascades also, everything a builder and the null aware operators. All these topics could be covered by clicking on their links. It will be very good if you can go to some of them or all of them to increase your learning. So next week we are going to start working on the setting like the PC environment to work on Flutter. So we start working finally on building applications, user UI at the beginning. Thank you very much. See you soon, inshallah.